As I've been mentioning throughout the chapter, our goal in chapter 3 is focused on solving quadratics. But sometimes we have to do these offshoots that are things related to solving quadratics. Things like factoring, which is a form of solving quadratics. In fact, I'm going to tell you right now, if I haven't said it before, factoring is one of the most important forms of solving quadratics, and it is also universal to other things that we do throughout math. So if you are struggling with factoring, you need to come in and start asking questions, because it will come back up in many, many chapters in advanced algebra. Anyway, so we've solved by graphing, we've solved by square rooting, then we got to solving by factoring after talking about factoring. Yesterday and the day before we talked about imaginary numbers and their effect in solving. So, today we're getting back to solving. We're going to solve. I don't want any decimal answers in what we are solving today. We start with one like 2x squared plus 6 is equal to 0. Now, when it comes to solving quadratics, the many ways that there are available to you all have their advantages and disadvantages depending upon the problem you're working with. A way that we've already been solving is going to be the best option for solving an equation like this. To solve an equation like 2x squared plus 6 is equal to 0, are we better off graphing, using square roots to solve it, or factoring? Square roots. Because of the fact that the only place you see an x is squared, the easiest way to solve it is going to be using square roots. Where do I start? Minus the 6. I get 2x squared is equal to negative 6. What comes next? Divide by 2. I get x squared is equal to a negative 3. Now what? Square root. When you square root, what do you need to remember? Plus or minus. X is equal to a positive or negative, whatever the square root of negative 3 is. Can I simplify the square root of negative 3? You can always simplify the square root of a negative. At least a little bit. Because what's the negative inside the square root going to give you? I. So I pull out that I. Can I simplify the square root of 3? To simplify a square root, if it's a perfect square, you just square root it. It's not a perfect square. If it's not a perfect square, you ask, does it divide by a perfect square? Other than 1? No. Then you leave the answer like that. X is equal to a positive or negative I square root of 3. This is the absolute easiest way to solve this problem. Okay? Let's talk about another one. And this next one is one that we have set up already in a form that we should know how to solve as well. (2x squared plus 11x is equal to a negative 5). Do I want to solve it by graphing? Generally speaking, you only solve by graphing if you're given the graph. It's the worst way to solve because you have to go through all of the work of graphing it, not knowing if it's going to get you an answer at all. So we don't do that. Can I solve using square roots? No, because there's a regular x. There's both an x squared and a regular x. The moment there's a regular x, you cannot solve via square roots. So instead, we're going to solve by factoring. If you are going to solve by factoring, your first step is what it is equal to. It has to be equal to 0. It has to be equal to 0 because to solve by factoring, you have to use what's known as the zero product property. It only works if you have something written as a product equal to 0. If it's not equal to 0, factoring is not helpful. I had the 5. 2x squared plus 11x plus 5 is equal to 0. When factoring, I should always start with the greatest common factor, because if there is a greatest common factor, especially if it involves a variable, you're going to make your life a lot easier. Greatest common factor is 1. The smallest number here is a 2. 2 only divides by 2 or 1, and dividing by 1 is not helpful. And 11 and 5 do not divide by 2, and there's not a variable in all of them to factor out a variable. So greatest common factor wasn't helpful. I got 2 follow-up options. AC method or its shortcut. Why the full AC? Because A is not 1. If you struggle to differentiate the AC method and its shortcut, the full AC method will always work. You don't have to do a shortcut if you know how to get there the long way. If it's easier to do that. AC method says to do what? A times C. It's called AC method for a reason. Find AC. 2 times 5 is 10. Look for 2 numbers that multiply to 10 but add to 11. I'm guessing we can come up with 1 times 10. Can I go directly to the parentheses when doing the full AC method? No, I have to do the rewrite. I have to change this 11x into these 2 numbers. 2x squared plus 1x plus 10x is equal to 0. Crap. What did I forget? Let's try that again. 2x squared plus 1x plus 10x. Don't forget the C equals 0. Why do I want it in 4 parts? So you can break it in half. Out of each half, you find the greatest common factor. What's the biggest thing that divides out of 2x squared plus 1x? 1x. Leaving me with a 2x plus 1 when I divide it out. What's the biggest thing I can divide out of 10x plus 5? Yep, I heard it. 5. Divide by 5 and I'm left with 2x plus 1. My parentheses match. Good thing, bad thing, or do we not care? Good thing. If it does not match, you have a problem. Now, I've noticed a number of people either forgetting to do the next step or struggling to understand how we go from this step to the next step. So I'm going to take a step back real quick, talk about factoring a little bit. Factoring is undoing distribution. Undoing FOIL specifically. When you see something like this, you should FOIL it out, right? Would you agree with me that when you FOIL it out, you start by multiplying A by both C and D? And then you multiply by B by both C and D. It's almost as if you have this. Where you distribute the A and the B separately. When we are factoring, when we are at this step, our next step is like taking something that's in this form and moving backwards to this form. Recognizing that since the parentheses are the same, I can move these 2 things into one set of parentheses together and then keep the other parenthesis. I've had a lot of people asking about how the next step comes out. That's where it comes from. The 1x plus 5 were the greatest common factors. because those can go together to say they're both getting multiplied by c plus d. The other parenthesis was the 2x plus 1. Am I done? No. I haven't solved anything. How do I solve once it's factored? Take the things getting multiplied. In this case, they are binomials. If a greatest common factor had a variable, that greatest common factor would also be set equal to 0. It's the zero product property. You'll get x equals a negative 1/2, and you will get x is equal to a negative 5. These are the two main form of solvings that we've done so far. Solving by factoring, solving by square roots. Yeah, we talked about graphing, but graphing really only works when you're given a graph. X squared minus 10x plus 7. Could I solve by square roots? No, there's a regular x. So I would try to factor. Greatest common factor is 1. Would I do the full AC method or the shortcut? Shortcut. And I would look for two things that multiply to 7 but add to a negative 10. What are the only things that multiply to 7? 7 times 1. Or negative 7 times negative 1. Either way, am I adding up to negative 10? No. We've got some missing things. We're missing a key form of solving. That's where completing the square is going to come into play. Completing the square essentially tries to merge together some of the key things with solving by square roots and some of the key things that can help you by factoring. The way that it does this is it works with what's known as a perfect square trinomial. A perfect square trinomial is a polynomial, a quadratic polynomial, typically, written out in standard form, hence trinomial. It's got its 3 parts, but it was the result of squaring a binomial. It's a standard form quadratic that could have been factored into something that looks like a plus b squared or a minus b squared. Perfect square trinomials are hugely helpful to work with because if you have something actually written in the form of a perfect square trinomial that has been factored, in other words, if you have something written let's do something like this. As x plus 5 squared is equal to 50, this is a perfect square trinomial. And if you have a perfect square trinomial in its factored form, how can you solve? Using square roots. So, if I can make it where I have a perfect square trinomial equal to a number, it gives me an option for solving. So if I can make this a perfect square trinomial in its factored form equal to a number, I can solve. So let's look at what a perfect square trinomial looks like when it's not in its factored form. To square a binomial is to multiply it by itself. And when I FOIL this out, I get a squared plus ab plus another ab plus a b squared, which means it results in a squared plus 2ab plus b squared. For quadratics in which the first term is an x, it would look a little bit more familiar as an x squared plus a 2bx plus a b squared. I want to make this have this structure. First thing I'm going to do is I'm going to move that 7 out of the way. I don't like it there. It's not helping me get my perfect square trinomial piece. So I'm going to move the 7 to the other side. I want it as x squared minus 10x. I'm going to leave a gap before my equal sign. There's a reason for that. Equal to negative 7. Gesundheit. Now, if I want it to be in this form, I've got the x squared, that part's taken care of. This right here has to be my 2bx. And then this piece right here, that's open spot, I need it to have a b squared. That means this right here, that negative 10x is equal to 2bx. What does that make b? Negative 5. The x's can just divide off, and you got negative 10 equals 2b divided by 2, and you get negative 5. I want that right there to be b squared. What's negative 5 squared? 25. I want a plus 25 happening right here. Here's the thing. I just changed my equation, though. I added 25 in a way that I can't do. You can fix that, though. Because if you add 25 to one side of the equation, how can you balance it out? Add 25 to the other side as well. Now, that adding 25 didn't do anything. Yeah, it looks different. But the actual equation itself could still go back into the form of x squared minus 10x plus 7 equals 0. Okay. I wanted this form with the goal of factoring it and getting it back to this. So I want to factor x squared minus 10x plus 25. Because with how I built it, it should turn into something squared. Shortcut or full AC? Shortcut. Two things that multiply to 25 but add to negative 10. Negative 5 and negative 5. Which means it factors into x minus 5 and x minus 5. Still equal to that negative 7 plus 25. And if you prefer, we can simplify that. It becomes 18. X minus 5 times x minus 5 is x minus 5 quantity squared. The moment it's in this form, I can now solve using square roots. To solve using square roots, first thing I do is get the squared part alone. Done. The second thing I do is I take the square root. When you introduce the square root to a problem, you remember to put what with it? Plus or minus, on this side, I'm left with x minus 5 equals positive or negative square root of 18. Can I simplify the square root of 18? It's not a perfect square, but it divides by 1. What perfect square does 18 divide by? 9. X minus 5 equals positive and negative square root of 9, and it's 9 times 2. X minus 5 equals positive and negative. The square root of 9 is 3. Square root of 2. I want to get x alone. If these are like terms, I would split into two equations. Are they like terms? No. Like terms require same exponent, same variable, but that includes same square roots involved. This one doesn't have a square root, this one does. They're not the same square root. So, they are not like terms, which means I'm not going to split it into two separate equations. I am simply going to add the 5. X equals. Start with the number you added or subtracted. In this case, I added 5, so it's positive 5. If I had subtracted 5, it'd be negative 5. Plus or minus 3 square root of 2. This form of solving works when you can't use square roots because there's a regular x, but it's not factorable. Because factoring only works if the answers are rational. It only works if the answers can be written as fractions. It doesn't work if the answer has to involve a square root. Okay. Got a couple more examples of completing the square. On the next example of completing the square, I'm going to write the steps to completing the square alongside it, because I know full well that some of y'all are probably like, okay, I could kind of follow what you were doing, but I have no clue how to do it. And I get that. So, if you want to complete the square, first thing you need to do is to get in the form of x squared plus some number, I'm going to put dx, with a space equal to some number e. It's the first thing you got to do. You want that form for completing the square. Where do you think I should start to make that happen here? Yes, but no. Yes, but no. First thing I'm hearing is greatest common factor. And yes, you can do the greatest common factor, or you don't always want to do greatest common factor, because greatest common factor implies that the number divides out nicely, which doesn't always happen. I want just x squared. I don't want 3x squared. I need to get rid of the 3. Because it is not purely a factoring problem, it is a solving problem, I can do opposite operations, the do it to one side, do it to the other type of thing. How would you typically get rid of a 3 in front of something that you don't want it to be there? Just straight up divide. Divide by whatever that number is, even if it doesn't divide out of everything nicely. Am I going to do a whole lot that it doesn't divide out of nicely? No. But is it possible it doesn't divide out nicely? Absolutely. X squared plus 4x plus 5 equals 0. Am I in the form that I want? No. What's the other thing I got to do? Move the 5 over. X squared plus 4x, leave a gap, equals negative 5. Step 2. Technically, the step says to find what makes the left side a perfect square trinomial. That's what the step technically is wanting us to do. But what that is always going to fit the same structure. I'm going to bring up my perfect square trinomial structure again. Essentially, I need to figure out what I want to add right here. The number I add right there in order to have a perfect square trinomial is equivalent, when in this form, to this b squared piece. How do we figure out what b is? We have this, we have this. B is right here. It's hanging out in front of x. It's 2b hanging out in front of x. I just want regular b, so what am I going to do with 2? Divide it, get rid of it. So, what that number will be that goes right here is whatever this is, divided by 2, and then if I want to add it to both sides, I need its squared form. So when it says, find what makes the left side a perfect square trinomial, take that d, divide it by 2, and square it. I do that off to the side. Okay, in this case, it's a 4. 4 divided by 2 squared. 4 divided by 2 is 2. And 2 squared is 4. So you find that number and you add it to both sides. Plus 4 plus 4. Factor the left side. When you factor the left side, you should be able to do the shortcut method every single time. Because you should have a 1 in front of your x squared because of the first step. 2 things that multiply to 4 and add to 4. 2 and 2. It should also always be the same number. In fact, it should always be the whatever d divided by 2 number was before you squared it. X plus 2, x plus 2, or better yet, write it as x plus 2 getting squared. What's it equal to? -1. -5 plus 4 is -1. Solve by square roots. Don't forget the plus or minus. Squared term should be alone, so I take the square root. X plus 2 equals positive and negative square root of -1. Simplify the square root of -1, and what do you get? Square root of -1 is just I. I squared is just a regular -1, not a square root of it. Are these like terms? No. If this was a plain number, if it didn't have a square root, if it didn't have an imaginary on it, then I would split into 2 equations. X plus 2 equals I, and x plus 2 equals negative I. When they're not like terms, I don't have to. I just have to get the x alone. How do I get the x alone? Subtract 2. X equals, what do I start with? Negative 2. Plus or minus I. Okay, got one final example. This final example, for the sake of the notes, I'm going to go through it up here on my own, and I'm going to have you try it out on your own. When I am done going through it up here, then I will be coming around and checking on people. By the way, what happens when you square a negative real number? It becomes positive. Keep that in mind.